Hey guys, welcome back. And again, this is Algebra 1, Chapter 1, Section 3, and we'll be getting into example 4. But what I wanted you guys to look at here was this is what's in your notes. These are the steps you should be going through every time. That's what I was saying last time when if you're solving equations and you say, I just don't know what to do and it's blank, when I talk to your parents, it's going to be flat out. You're not telling them the truth because these are your steps. Did you try to use a distributive property? Did you try to simplify the expression on each side? Did you try to collect the variable terms? Oh, I don't know what the distributive property is. You didn't watch all the videos because it goes back, and I'll be able to go back and say, here's the video, here's where it showed, okay? And I don't expect that to be an issue, especially after meeting all the classes and everything. I don't think that's going to be the issue. Having the guts to try might be the issue. You've got to step out. If you get it wrong, you get it wrong. You're going to get it wrong a few times. So now, and this is a really good thing too, when you're doing an identity, one thing you'll be able to know if it's an identity, if you look at the original problem, you can plug in a bunch of numbers and they'll work, okay? So that was just a study tip on that. Now let's get into example 4. This is a great problem and is also a high-level problem. I won't say this problem divides the A's and the B's. This divides the A pluses and the A's. Okay, this is that tough of a problem. But after you learn it, there's one just like it right after. It's really not that hard. Some of this I'm going to show on the whiteboard too. So a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Okay. So this is a tough problem. And in mathematics, this is going to happen a lot. You're going to have problems that seem really tough. I can do a lot of math, but I've never invented anything. I've learned things other people have done. So when you learn how this problem works, when you see other problems like it, now you'll know later. Okay, so don't think into it too much if you don't know how to do it yet. Okay, so let's understand the problem. You're given the amounts of time the boat travels and the difference in speeds for each direction. You're asked to find the distance the boat travels upstream. Okay, so we have a couple things that could be going off our head right now. We have the distance formula. We thought things sometimes it's not always distance formula, but right now it looks like we have distance formula because we're not just talking about distance. We're also talking about times and rates. When you have those three being talked about, 99.99999% of the time, we're going to be talking about distance formula. Okay. Now, use the distance formula to write an expression that represents the problem. Because the boat travels in both directions is the same, you can use the expressions to write an equation. Okay. Now, I'll draw a picture of it. They're going to just write it out. So we know distance equals rate times time, back to the happy circle I talked about. The distance upstream equals the distance downstream. Okay. That's pretty straightforward. I'm going to use upstream in blue and downstream in red. Okay. You can't see my board right now, but I'll show it to you in a second. This is if you can do everything algebraically. Let x be the speed in miles per hour of the boat traveling upstream. So we see how we have the speed upstream times the number of hours we've been traveling equals distance downstream. Now, this might not all make a whole lot of sense. But right here, remember, downstream, we were going 3 miles an hour faster, okay? And we traveled for less time. And it makes sense. We went the same distance. So if I went faster, it should have taken me less time, okay? So now I'm going to show that on the hovercam. These should be the same exact distances, okay? We went upstream, then we turned and came downstream, right? Well, the thing we are searching for, remember I said 9 times out of 10 our variable will be x is going to represent my speed upstream. Why? Because they told me that's what I'm searching for. Does that make a little sense now? And we know distance upstream will equal distance downstream. That's why I did du dp. Okay. Now I'm going to show my distance up, my speed and rate upstream because we know that equals the distance. I was going for 4 hours. that is my time, at a rate of X miles per hour. That is where the 4X comes in. So my distance upstream can be shown as 4X, okay? My distance downstream. Well, this was a little bit harder, and I need to make sure I keep checking. 2.8 hours. So my time that I traveled on this was 2.8. The speed that I was traveling is 3 miles an hour faster than the speed upstream. So it was upstream plus, what was it? 3. Yep. And that is my distance downstream. So hopefully that makes sense where we're going to get our equation from. I know the distance upstream equals the distance downstream. I know I can represent my distance upstream as 4x. 4 hours traveled times the speed of x, okay? So now I'm starting to fill in my equation completely. I know 4x has to be equal to 2.8 times x plus 3. Now take a second, because this is the hardest part of it. 99% of the time, the hardest part of all of our story problems will be writing the equation. We're going to work so hard on solving equations. I can throw any equation out. This is easier than most of the equations you've already done. So now it's just building it. Make sure you go back, look back at my video, look back on the Big Ideas videos. Make sure you can explain where these come from, okay? If you can explain where this comes from, the next problem won't be as hard. It's almost the same problem, just with different numbers. And you'll notice as we go through math, a lot of times that's what happens. There might be a little tweak in scenarios, but not much. So I know theirs looks a little bit different. They're doing physics. They're showing more of the physics problems by putting in the miles and the hours and canceling. It's not a bad thing to do. It's just not how most math people do it, okay? It would be the 4x, how I showed you. 4 times x equals 2.8 times x plus 3. And that's where we were right at on our board. So now we're solving. We're going through our steps of solving. Unfortunately, this showed it. I apologize. Maybe I double-clicked it. First thing you look for is to simplify each side. Nothing to do on the left side. The right-hand side, we need to distribute the 2.8. 2.8 times x gives us our 2.8x. 2.8 times 3 gives us our 8.4. We already have the variable only on one side, so we can skip that step and go to the next one. Get everything else to the other side. So we need to get rid of this 8.4. How do I get rid of plus 8.4? Subtract 8.4 from each side. Excuse me, I just made a mistake on that. I wanted to get rid of, I did have x's on both sides, so I need to get rid of the 2.8x. I apologize. I was kind of looking ahead. So I'm going to subtract 2.8x from each side. 4 minus 2.8x is 1.2x, and that will equal the 8.4. Now I have all my x's on one side. Final step, to get rid of the times 1.2, we have to divide by 1.2, and we're at x equals 7. So remember what x represented, though. We went to the very beginning, and we identified x to be something. We identified x as the speed upstream, and that's what we were searching for. So we just solved it all, and we got it, and we're done. Okay? So if they would have asked us for something else, the speed downstream, which might be a good extra thing, that's something we can talk about in class, the speed downstream. Or actually, let's just go to our model. We know x is 7 now, right? Because we solved all that, x equals 7. This part right here represented our speed downstream. So if they asked us, obviously to be faster, 7 plus 3, you traveled 10 miles an hour downstream, okay? And when you multiply them out, 10 times 2.8 is 28. 7 times 4, 28. We did everything correct, and we should be pretty proud of ourselves because that is a very difficult problem. So go through this a couple times. You may need to. I know when I was your age, I had to go through these a couple times. And now that you have YouTube, you can hear me say it a couple times. You can hear someone else say it. But take the time with it. Thank you guys very much. Good luck on your monitoring progress.